Yes.
Excellent. Okay. So let's get straight to it. Apologies, I'm 9 minutes late. So we'll try and get through the first bit as soon as we can. This is going to be our agenda today. I can't remember an awful lot about what happened last week, so I'll open it up to the floor so that we can just have a quick review. I'm conscious of the fact that we start a little bit late. So these are the dates that the other guys are going to be hosting. Hopefully they'll do a better job of getting stuff started than I did. And the study group, right? So we meet on the Slack channel if this is the first time you're on, and we have these weekly sessions on Zoom, and it's normally at this time on a Saturday. So we've got a rotating host policy. So as I showed you in the previous slide, we have different guys hosting the session for each week. So I think we're going to be coming up to an interesting week where there's going to be like a 2-week break between the Fast.ai session. So that's between lesson 6 and lesson 7, but we will continue to meet up on the Saturdays. Right. Okay. So any questions or any comments from anyone before we have a quick recap of Meetup 4, please? Okay, fine. So let's have a quick recap of last week. I remember. Sorry, I don't. I was actually on. I remember a good chunk of last week. But can someone? So I know that Sanyam provided some sort of a review of the Doodle Challenge, which is the Kaggle competition that's going on. Christian, I can't remember if you did something on your guitar stuff or whether it was a previous week. Does anyone else remember what we did last week?
You mean like what actually happened in the lesson?
Yeah, we had 2 projects. I mean, we had a couple of mini presentations. I can't remember what they were. I think one of them was the Doodle Challenge. I just can't remember what the other ones were.
You mean in our meeting, not in the actual lesson?
No. I mean in our meetup.
So many meetups going on.
Sure. Okay. You know what? I'll tell you what. Let's just crack on with what we're gonna do for this week. Okay. I'm just gonna share something with you very quickly. Any general thoughts about lesson 5?
I think it was an interesting lesson. I think covered a lot of stuff as usual. Some Excel work again.
Yeah, I think it was pretty intense. Maybe it was me like really tired and sleepy, but it was kind of a lot of content.
Yeah.
Yeah, it was the first time for me that on the second half that I really had to, it was hard to understand.
I had to rewatch that as well.
Yeah, okay, so I'm grateful I'm not the only one because I actually thought it was really very, very intense. I was struggling to hang on. So I mean, just in terms of us trying to just summarize some of the parts of the lesson, I'm going to just share this. So basically the first part, sorry, again, give me a second.
By the way, whenever Jeremy goes into Excel, I think of Christian starting to fall asleep.
I don't know what that is. Excel just makes me freak out. But I mean, he's doing it as an art form, so he's doing it really well. So I don't mean that it's not serving a purpose, but I don't know. Excel is, I have seen too much bad Excel maybe, or I don't know.
I was talking to a ham engineer the other day, and strangely enough, he's from Russia, and his name is Mikhail, and he has red hair too.
Oh.
But he's in his 60s.
Yeah.
But the interesting thing was that he didn't, apparently we're going to, as we share with other people that we're doing machine language, some people are not going to agree and they're going to have some knowledgeable arguments. And he apparently studied it to the extent that he understood some of the limitations with random forest, that you can't predict. It's not a good predictive model. And, but apparently he hadn't been exposed to CNNs or RNNs yet, so, or even, what is it, reinforcement learning, so. But anyway, so I just thought I'd share that. Aside from the point that I'm still getting a headache from last class's meeting.
Okay. I had one comment on the early part of the lesson. I think it might have cleared things up more for people when Jeremy talked about the freeze and unfreeze and drew the diagram and mentioned how, well, kind of more of the details of what's going on. I think that was a question in this study group a couple of weeks ago about what really is happening with the final layer and the other layers. And he spelled that out more clearly in the
Absolutely. I thought he did a terrific job of that. Okay. So basically what I've got is I've got a list of a couple of the things that were covered. So perhaps we can do that. But before I just provide some sort of review of lesson 5, is there anyone who has something that they want to demo? Because I don't think I've seen anything. I don't think anything was sent to me on the Slack channel, but just so that we know what we have in terms of time. Is there anyone who has anything that that they'd like to demo? Now's your chance to shout. Okay, cool. Right, so one of the things that was covered was, I'll tell you what, let me share my screen. That might help you see some of, so I just took a couple of notes of what I saw. Let me know when you can see this.
Yep.
Okay, sorry, I did want to try and clean this up a little bit, but I've just had a mad afternoon. So one of the things he covered was discriminative learning rates. And, he spoke about how...
Sorry, could you just widen it a bit?
Sure, oh, apologies, hang on a sec.
maybe make it fill your whole screen.
Yeah, bottom right.
Thank you. Whoop, hang on a sec.
Cool.
Yep, does that work? Okay, so let's try. Okay, cool. So one of the things was discriminative learning rates. This is what he started off with. And he said, there were 3 types. One was basically you have the same learning rate throughout, and that basically isn't discriminative learning. And then you have the slice and the option of the second parameter for the slice. Any thoughts or comments on this, on the discriminative learning rate?
Yeah, I don't recall how many slices it does. I think in the previous version of the library was only like 3 maybe.
Yeah, I think you're right. I think it's still 3.
Okay.
Yeah, he said that the final, he replaces the final layer, like the one with 1,000 for the 1,000 classification problem. I think ResNet 34 is trained with. He replaces that with 2 layers separated by a ReLU, and that's what he calls the final layer.
Mm-hmm.
But then everything else in the architecture, he splits in half. I'm not sure, he didn't really say how he does that, but that's where the other 2 layers come from. The entire rest of the architecture.
Yeah,
that's divided into 2 different groups. Yeah,
that was my understanding also. But yeah, I also don't know how he actually splits the other 2. But this thing of grouping things together was new to me. So yeah, any other thoughts or comments on that?
I'm still a bit confused, to be honest. Maybe I think it was repeated in the lesson, but I forgot about if you actually do the learning rate finder twice, like after the unfreezing or not, or if you just carry over the initial learning rate and then there was like a divide by 5 or something. Can you remember? There was something where he did basically with the frozen model some kind of learning rate finding and then just reused this learning rate but modified it when he unfroze. And I don't know if that was a general rule or whatever, because there was some discussion in the forums as well, like if you should find new learning rate, because in my experience, the plots just get really weird when you unfreeze. You never get this nice kind of curve with, or at least in my cases, I don't know if I'm doing something wrong. Do you guys unfreeze and then find a new learning rate?
Yes.
Okay.
Yeah, this is also how I try to do it. Yeah.
Yeah, I think that's what he did in the first lesson. That's why I do it too.
Okay, maybe I don't know. I think in the last one or sometime he didn't do the relearning, or maybe it was for the NLP thing and then just reused the initial one. I don't know. I have to rewatch some of these lessons.
I have a question. In the slice, we only provide the 2 learning rates. What happens to the last layer, that head that we create, that we train?
That has the E minus 3.
Yeah. So if you give a slice with 2 arguments, the second argument is the learning rate for the final layer, and then he does some multiplicative factors. The first argument would be, I guess, the learning rate for the first group, the first half of the architecture, and then there's some middle point that he interpolates, and that would be the next group 1E minus 4 would be the second half of the original architecture learning rate.
Slice gives you a range, basically.
Yeah.
So for all architectures, it would be 3 groups, basically, always.
That's what he seemed to suggest, that's what his implementation was. But yeah, that was my understanding. But
I mean, maybe he tried originally to be more fancy and divide it into more groups, but in the end, he thought it was good enough to just divide the given architecture into 2 pieces plus the layer at the end, and that was enough flexibility.
Yeah, there are many different ways you can specify that. You can just say a number, and then it's going to assume that's the, I think that then it's done for the entire network, I guess. Okay, before I'm freezing. But you can also give like maximum max LR, max underscore LR. And you also can give like a slice. I would need to look into the documentation how it should be specified.
Yeah, it's a bit confusing because there's so many ways to specify it.
Yeah. In the documentation, it's got like a learning rate is slice of 3 numbers in brackets. But some of them are by default none, so you can actually not give them. So just 1 number works as well. Yeah.
I think with 1 number, he said, like, if you just give 1E neg 3, then the previous layers will get that divided by 3 by default.
Yeah.
Okay.
I think that's what I also got. So the last layer has a learning rate of E minus 3, and then everything else divided. But he said that was too complicated to get into, why we did that. And he said, yeah, so he might get into that next week or the second session of the course. So yeah, okay, cool. Let's move on to the embedding bits then. So the next section that he covered was, one-hot encoding and embedding. So, and what I got from that is embedding is identical to matrix multiplication by a one-hot encoded matrix. Then there was this interesting thing about latent factors and features, things that are hidden that appear when we train the neural net. And the example that he gave with John Travolta and films and so on was a very interesting one. Any thoughts or comments on latent factors and embeddings?
I understood it as a better way of doing one-hot encoding, like instead of hard coding it to 1 or 0, let the neural net compute the values between 0 and 1. So the relationship is captured in a better way between the features.
Regarding the latent factors, he did an example where he had 40.
Yeah.
And that one, you could say disadvantage is you have to choose that in the beginning and you don't know what it is. He chose 40 and then in the end he used PCA to bring that down to 3 and then tried to make a plot of that. So that one, I don't know if you need a lot of practice to help to decide how many latent factors you should start with. I think you just have to try out different values and see what ends up working well for you. And then in the end, if you have a lot of factors, you probably need to, well, it might get hard to visualize. So that's why he did the PCA thing.
And I think he was also pointing out that sometimes latent factor can be examined and then you can actually see that you can actually understand what pattern your network has found. And I think, I don't remember the specific example he was giving, but I think he was, in one example, a high value of the latent factor meant it was like a highbrow kind of intellectual movie, and a low value meant it was kind of like a pop or, least common denominator kind of movie. So sometimes if you examine the latent factors, you can actually make sense out of them, but I don't expect that this will always be the case.
Okay, so I've got a really silly question because I've just, so, when you talk about embeddings and factors and so on, what exactly are we referring to in a neural net? What aspect of that is that? Or is that something that's in this spreadsheet example?
I think when he started talking about Excel, the number of latent factors would have been correspond to the number of the height, the number of rows of the matrix that he put on top of the main matrix. I think he had 5 in his original Excel example, and then he put a bias row on top of that. So I think there he was using 5 latent factors. And so that matrix had 5 rows in it.
Yeah, these things are weights, and these weights and biases are the neural network is going to solve for them. Like you were saying, instead of one-hot encoding some feature, you're letting the neural network assign, values, real values to these latent factors that will then encode the feature.
Yeah, so neural networks only work well on the continuous data, but in real world we face a lot of times there's categorical data as well. So suppose you have 7 days of a week in your data, like 0 to 6, 7 days. And for that, if you create a embedding matrix of the size 4, the rule of thumb, I think, is number of categories by 2 or 40, whichever is lesser, as far as I know. So you create a 7x4 matrix. So in your input data, whenever a row like day, Sunday for index 0 is present, it will append those that row corresponding to 0 in your input data, and through gradient descent or whatever optimization step, it will compute the actual vectors which are initialized randomly initially. So it would be a lookup matrix kind of a thing.
Okay, great, thank you. So one of the things that I couldn't figure out was, I thought this Excel example was brilliant. It just helped visualize stuff much more easily. And then, he was talking about how the example he gave was, so if your assumption is that someone likes John Travolta movies, but that you've got this that you don't like because it is John Travolta, but why don't they like it? And then he was referring to that being like the bias, right, for your in your neural network. And then he mentioned, then he went into how this extra column that he was adding was going to be the bias, right? So the one on row 19, the one that I'm highlighting now, this is your bias here, and the bias.
We just see the Word document.
Oh, right. Sorry.
You need to pick the other window, yeah.
Apologies. I thought I was sharing my screen. Let me share my screen.
Yeah, excellent.
Yeah, sorry about that. Okay, so so basically he was talking about how the bias is actually this. He adds this extra row at the top for the movie IDs, and he added this extra column out here, and this was the bias that he referenced. Now, what I couldn't figure out is where did he actually get these numbers from? Because if I look at the if I look at the cells, there's nothing to suggest that there's any formula or anything associated with them. Does anyone know?
I think they just randomly assigned as everything else, and then the network would learn what that bias should be. So you start with complete random numbers as with the other embeddings, and then it will learn what it should be.
Isn't bias supposed to be a single real number?
For each user, there's a user bias, and for each movie, there's a movie bias. Yes, and they're single real numbers in each case.
I mean, you might well be right about these being random numbers. I thought they were random, but then I thought I'd see a random function here, and I couldn't figure out why I couldn't make any sense of those. Okay, that helps. Any other?
Well, I haven't looked at this, but do the other weights have formulas associated with them then in that spreadsheet?
No, they don't. So nothing in this top row which corresponds to biases, and nothing in this column which corresponds to the user biases has a function.
What about the other rows and columns of that matrix?
Oh, these ones? You mean these ones?
Like right underneath bias. Sorry, right underneath bias. Does that have a formula associated with it?
These ones?
Yeah.
No.
So none of them have a formula associated.
No, but these are the latent factors, right, or whatever they're called.
Yeah, those are weights, I guess, right?
Yeah, they have to be random too.
Yes. Yeah. So I guess yeah. So I guess what's happened is he's just created some random numbers here. I thought there was something else to it which I couldn't figure out. Okay. I think that might be it. Any other thoughts or questions around the bias and latent factors?
Yeah, I really hadn't thought about bias before, but now I realize it's a thing because, like, when I review, Yelp sites or whatever, I tend to only review the sites that I really like. I tend to only review things that I really liked or that I really hated. So there is kind of a bias there.
Yeah. No, and his his example about the anime thing and all, that was really very, very helpful because yeah, just around how important the bias is. I think I've taken it for granted, because you just see it as you multiply the inputs by the weights and then you just have a plus B for the bias. Sort of made me realize how important it potentially is. Before we get
so the interesting for me was that the bias is always addition. Like, so I would be thinking that you could maybe play with it and your bias could be maybe something else, some other function.
Why? But it's a linear model, so I think you're right. I mean, you could make it more, but I think that in this singular value in this stochastic gradient descent model, we're trying to work with a linear model. So it's an affine transformation, a matrix times the vector plus a constant.
And,
Yeah, that's right. That's right.
Mathematically, also, if you're trying to find a function, what we are actually trying to do mathematically is trying to find the correct function as close possible to reality. So consider a straight line, y is equal to mx plus c. If you do not add the c, you can only create lines which pass through the origin,
Yes.
right? So if you do not add bias, then you're limiting your mathematical function.
Mm-hmm.
Yeah, I think that point about, the reason why it's an addition, I think that's quite helpful actually, is because it's, at the end of the day, this is just matrix multiplication. And if you wanted to provide that, then that's why you had the addition there. Thank you, that's quite helpful. Yeah. Any other thoughts on the bias or? Okay, so let me.
Yeah, and maybe the bias is just one number. Maybe you could create like more reach again if you have more numbers than just one. I'm just thinking why is it designed in that way? I think it makes sense. But so the embeddings, we have like 5 numbers, and then the bias is just one. What if we created the bias of 5 numbers? Would that give even better, more richer representation of that? Could be. I'm just kind of a little bit surprised why is it so strict. So this is the way, and nothing else works. Maybe.
I think because it's the embeddings just capture the kind of diversity anyway, and this lifts it up and down. So that I don't think there would be a point in having more biases.
Okay, could be.
Don't cite me for that.
Yeah, I'm just thinking about it.
Maybe in the example of a straight line, like y equals ax plus b, you have you have one dimension there. But if you had 10 different dimensions, you still would just have the one bias term, because right, because if you add more, plus b plus c plus d, it's just equivalent to
plus something. Yeah.
You can combine them all together to be one of them. So very, very random question. Yeah, I've had my brain's struggling a bit here. These numbers here, right? The ones with the minus 0.18, 2.03, and so on. When you're looking at when you're referencing a neural net, are these are the weights, aren't they? That you're multiplying for each of the inputs for your fully connected between the fully connected layers.
Yes, I think the product of the matrix at the left times the matrix at the top is supposed to be the weight. I don't know if I'm making a matrix factorization. You're trying to take the ratings matrix, which is the big matrix, and break it into 2 factors, which are the matrices at the left and right. And the product of those 2 matrices, and I think there's a slight there's a slight tweak on this because you have biases as well to fold in, but basically the product of the 2 matrices, the one at the left and the one at the top, is supposed to be equal to the ratings matrix, and you're trying to solve for those numbers so that happens.
Cool. Okay, great. Before we go ahead, can someone please try and power up one of the notebooks from lesson 5? I can tell you which one, and then I'll ask you to share in a few minutes. So if you can first go to the lesson, sorry, my apologies, the lesson 4 one first, because I think he started off with that. And then we go to the lesson 5 one. So if someone can volunteer to do that, and then because I don't have that I don't have anything, any of those notebooks up on my screen at the moment. So that would be.
Which notebooks again do you want?
So if you can have both, please. If you could have the one from lesson 4 that he started off with, and then on to the one that he used for lesson 5, please.
Okay.
Okay, so if that's that for factors and so on, then I'm gonna move. Sorry, I think I'm sharing my. Let me get the Word document out again. Right. Okay. So this is with reference to the lesson 4 notebook, the one that he started off with. I can't remember what the section is, but he goes into, you know, this embedding.bias stuff, and then there's learn.model, and he provides this this example here. Was anyone able to make sense of this bit? Because I couldn't figure out where this learn.model and this embedding.bias thing came in, why we ended up with these numbers. Can everyone see my screen?
Yeah.
So it's this bit here, and it's from the lesson 4 notebook.
So I think 40 is the embedding matrix size,
Yeah.
which is 5 in the Excel, and 944 is number of input, number of users probably, and number of items is 1654.
I guess that's that's user, right? I is.
Yes, U is user, I is item, and
Okay, yeah.
each one has a single bias number.
Yeah.
Okay, I think you're right. Yeah. So the users and the associated parameters for those. Okay, cool. Thank you.
So, and 40 was again like his kind of upper limit, like default upper limit for number of embeddings, or what was that again?
So he tried 80, 40, and 20, and he said 40 worked best.
Or like you mentioned, or someone else mentioned, like half your category number, right?
Yes, so in the last version of the course, he said his rule of thumb was to half the number of categories, or 40, whatever is lesser.
50, I think it was the last time, yeah.
Or 50
Yeah.
probably.
Can I ask a silly question? When he said he's trying 80, 40, and 20, right? How are you actually determining which one's giving, how are you determining which one's giving you a better value? What are you actually looking for?
Whatever metric we during training, accuracy or loss.
Is it cross entropy in this case, he said? No,
it's I don't know. It doesn't look like a classification problem to me. It should be RMSE probably.
Yeah, could be right, because it's how far you are from the true predicted.
But is it then that you don't need more, like you save computational space or memory or whatever, or is it that it's actually harmful to have bigger embeddings? I think he mentioned that it's to not waste memory, right? Or is there a drawback if you make your embedding size too big?
Yeah, I'm not sure.
Yeah, even I have no idea about
I
it.
think he mentioned that it's basically he wants to get by with as little as possible, but I can't remember if there was.
Actually, as I recall, Jeremy has said that the curse of dimensionality is a hoax, and that you should use as many variables as you can get away with. So I don't think he's afraid of using too many, but because he said you could always stop the overfitting by introducing regularization methods like dropouts and so on.
But then it's maybe a memory problem that if you make
yeah, that's the only drawback to using too much, to using a large variable size is the memory.
Okay, that probably was mentioning memory.
Okay. And then, he then moved on to talking about, he did principal component analysis, and he said how you can actually, for those 40 different dimensions, you can actually try and reduce them to 3 to see which ones actually make the biggest impact. And then there was this really interesting section on interpreting the movie bias and interpreting the movie weight. So whoever said that they could bring their notebook up, could you?
Yes, okay, which one is it? Lesson 4 collab or lesson 4 tabular?
So if you look, lesson 4, the lesson 4 collab.
Okay.
And if you could go to the section around the interpreting the movie bias and interpreting the movie weights.
Okay.
I found this really interesting is because I think he was trying to show that you can actually interpret. So, all along, you might have been very. Go on.
Sorry, I have it and I can share my screen, but I don't know how to do that. So let me know.
Right. Okay. I will see if I can. If I stop.
Okay.
I think you should have this. You should have the share content in the bottom middle.
I have a green button that says share. So if I press
that's the one.
That's right.
Take this one and then pick your window.
Pardon?
Pick your window that's actually your notebook. So you have to specify a window to share.
Oh, okay. Okay.
You can share like everything, or you can share specific application. Yeah.
But I'm still learning. So.
I got it. Okay, so this is the collab. Does everybody see this?
Yeah.
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 That's the one, yeah. So if you go down a little bit lower, please, yeah. So, you know, what I thought was very interesting about this thing was that he was basically trying to show that, you know, your neural networks is not a black box, but you can actually interpret some of these stuff around the, you know, around weights and biases and so on. And
Yeah,
this section was very, very interesting, but also I thought pretty difficult to understand. I mean, was that anyone so if we move up to the first section, please, you know, the one about interpreting the movie weights first or bias first?
I think he's weights. So this is what I was saying before. Where he, what bias?
I think it is. Yeah, that's right. Yeah.
Oh, there is movie bias. Okay.
Yeah.
So the first group.
Yeah. So I mean, would anyone like to take a shot at interpreting, or you know, how does this? Because he said this. You know, he gave different examples. So he said, for these are the ones that the movie connoisseurs would like, and these are the ones that people would like in general, and so on. Can anyone take a shot at well, basically providing some interpretation for the bias and how you come to that?
Well, I don't really get it, but if you look at the biases, all of them are not that far apart, really. The only two outliers are the first two. And they're not even that far out. The minus 0.32 and minus 3.326 and minus 0.324. And then the next one down is minus 0.2799. So I can't really see a pattern in those. They're not even that far apart.
Is that the movies that critics would like, or?
No, I don't think so. It's free will stuff.
Because the bias is minus, right? So if the bias is minus, I would say these are the movies that generally get lower score, I guess.
Ah, okay.
Oh wait, aren't these the hasn't he reduced the 40 factors to 3 factors with PCA? So he's just trying to now interpret I think there are multiple layers of increasing complexity. We first have these 40 latent factors, and then he converts that, maps those into 3, and now he's looking
what he's
at
showing here
the top 10 for one of them.
Yeah, what here he's showing the last 15, the bottom 15, that's the first group, and then the top 15 bias is the other group, is the next group. And I can recognize some of the movies in the top 15. I don't really know any of the movies in the bottom 15. But the movies in the top 15 are basically famous movies that got a lot of acclaim, right? I mean, Star Wars, Silence of the Lambs, Schindler's List, Casablanca. These are movies that have been acclaimed by a lot of people, and the other movies are movies that nobody's ever heard of. I mean, the movies at the low bias end are the movies that no one's ever heard of. So
yeah, I guess that makes sense. I guess it makes sense, right? Yeah.
So bias means something. Apparently, obviously means something.
You get better score, yeah. So the positive bias gives you better score, to my understanding, because once
correlated with higher scores, yeah.
Yeah.
But
and all of the negative biases are correlated with the scores in the twos. You know, so.
Can you actually interpret this stuff after PCA? Like
that's the thing, right? Because
PCA, it's found a pattern. It's found.
Yeah, sure, but I wouldn't like maybe I'm not sure, but I wouldn't like assign any weight on the direction, like negative or positive. I would say, okay, that's the spectrum going from left to right or top to bottom, but does the minus, the negativity actually carry a sentiment? No, it's.
Yeah, but look at the scores on the right. You know, so he gives the bias on the left, the tensor, and then on the right there's the actual score of the movie. And notice that all of the ones with high bias, and the bias in 0.4, 0.5 range, they all correspond to really high ratings, 4 point something. Yeah.
But
there
is
is a
it
correlation.
an effect of like the scoring? If the scoring would go from 1 as a school note super to 5 really bad, would it just flip? Like, do they actually reflect the
Yeah,
scoring?
I think they do, because the entire group of the bottom 15 are correlated with low scores. You know, the scores at the right are 1 point something, 2 point something, and the high biases are all correlated with the high scores and the 4 point something.
Okay.
The ratings, you know, and the highest rating is 5. So these are some of the top movies.
And there will be no PCA for bias, right? Bias is 1D, right?
Yeah, I think this is just straightforward bias from the learned bias.
Can you go up a little bit, please? Because I'm not sure if he's done.
PCA.
If he's done,
PCA would be for weights because
Yeah, the
that
weights
is
is
40
down below.
dimensional.
Where do I want to go, to the weights or above the biases?
No, sorry. I just the thing is, you know, we're talking a little bit about whether any PCA was involved. So
Okay, let's go back.
can you just confirm whether that's the case? Because
Yeah. Interpretation.
I think it's further down.
Because it's one
Further
dimensional.
down, you did the PCA down lower.
I think just from the movie bias, this we can start from there. Yeah, okay.
Yeah.
Movie bias, okay. Movie rating.
I think that's the pure bias without anything.
Yeah.
Right?
yeah, which helps, right? Because once you start doing PCA, then
Yeah, that's what made me confused, or at least suspicious. But it's the pure bias term, the actual bias term. Yeah.
Yeah.
Mm-hmm.
Okay.
Oh, thanks, Joseph. Actually, that's helpful to some of the. I didn't make.
Here's the PCA now with the
Oh,
weight.
okay. Whoa, yeah. So he does it for the weights, but not the bias. That's
Yeah, because the bias you only have one anyway.
Just
Yeah.
one number. Yeah.
Bias is
nothing.
one dimensional.
You don't have to reduce the dimensionality. It's just one. Yeah.
Yeah.
So the weights you have like 40, and
yeah,
he's
yeah.
bringing it down to 3.
Sorry.
but
Yeah.
I
Okay.
don't
Sorry.
know.
Thank you. Yeah.
Oh, there's the PCA. Okay. So he has factor 0, factor 1, and factor 2 that he extracts out of the PCA, and then now he's looking at
Factor 0.
factor 0 at first.
Yeah.
Multi-column.
Now the PCA is nice, but I like better the other visualization that Christian showed me. This is much better stuff.
But that's, I mean, PCAs to me are always intriguing. I mean, this one clearly is a nice pattern that these are kind of like classics on the top.
Yeah, classics. Chinatown, The Wrong Trousers, Ron. Yeah,
No.
I can't really, you know, maybe somebody who's really good at movies, who's really well versed in movie lore, could say, oh, the movies at the top are all, you know, movies that were done in between 1960 and 1970 or something like that.
I think they're like really highly regarded, like The Third Man. They're like really classics, or Casablanca and stuff.
Yeah, and then the ones at the next one, this level, are kind of like
Shitty.
lowbrow kind of movies, you know. And then the third one, let's see. And these are, wait, I'm sorry. This is still factor 0, and it's the last,
opposite. Yeah.
Yeah, the last 10, or the last 10, the lowest 10. And then this is the next factor. I think.
Yeah, factor 1. That's the second one.
Braveheart, Raiders of the Lost Ark. These are kind of like epic kind of.
I think he mentioned that the upper ones, they are kind of how to say, the edgy.
Yeah,
like, sure.
Edgy, yeah. Clockwork
like
Orange.
Trainspotting and stuff, like pretty cross and
Clockwork Orange too. It was really for that time. It was really.
Yeah, and the other ones are kind of blockbusters, kind of popcorn kino.
Yeah, Braveheart, Raiders of the Lost Ark, Titanic.
And so I guess PCA helps you kind of group things together and, you know, help make sense of it, and then you try and visualize it in that way. So
yeah,
it's a
and
bit
I
of
think
black magic.
sometimes you will see the pattern. You'll be able to put it in words and say this is what PCA has found. And other times you might not.
Yeah.
Especially if you go down like to the third or fourth eigenvector or whatever, then it gets like really hard to interpret. And usually. That was a good example.
Nice one, Joseph. Thank you.
You're welcome. Okay, I'll turn back the screen.
Oh no, don't.
Okay.
If you could now share Well, okay. And any questions from anyone on the embeddings? Sorry, not on the on this or any of the interpretation on the bias and so on.
I was wondering, like, to me, I haven't really used collaborative filtering at all. I was wondering, is there a way or a use case where you would actually combine it into a like more straightforward neural net? Or is it really a distinct application? Is there a case where you want collaborative filtering like as a pre-step maybe or something? Or I think he said something that he used embeddings for random forests as well.
Yeah,
Yeah,
he's gonna tell us about that later.
You could use the information from a collaborative filtering model and convert that into an input, for example, into a neural net in a conventional application.
Has anyone of you guys done stuff like that or seen it in action? I was kind of intrigued, but I haven't really seen anything like where it makes a clear distinction.
I've worked with a model of fraud detection in which your users are people who have credit cards, and your items are their transactions and things that they purchase. They're like stores that they, merchants that they go to purchase things. And you are trying to predict whether or not the credit card transaction is fraudulent, or how likely it is to be fraudulent, that somebody other than the actual card owner has made this transaction. And you could create a neural network model that has one of the inputs is the result of looking at of a previous training of this collaborative filtering type of idea, where you say this card holder tends to buy these tends to go to these merchants and buy these items, and that makes the person, according to some underlying latent factor, similar to these other card holders. So if I go to Los Angeles next weekend and buy a $5,000 set of golf clubs, maybe I've never done that before. So normally you might think your model should predict that as a highly probable of being a fraudulent transaction, like somebody stole my credit card. But according to this collaborative filtering model, it turns out that many people who have transactions like me, a lot of them do go to Los Angeles and make expensive purchases on the weekend. So even though I've never done that, it's actually not that likely to be fraudulent, because it's possible that because I'm like those other people according to the latent factors.
Okay, so it brings in a bit of context instead of a one-off.
So that's the false positive reduction technique, is to use that kind of a model as one of the inputs into the neural network.
Okay, interesting.
So Tony, your collaborative filter had users, and then it had stores as the items, or transactions as the items?
The items, let me think. I didn't build that myself. I'm not exactly sure now what the items were when building that model. There's a lot of information to choose from. You have people, you know, every time you swipe your card at a store or online, you get the date and time and amount and merchant identification and lots of pieces of information like that. So I'm not sure if there's some combination of things or what in the building of that model, that part of the model.
Yeah, one thing that seems, I mean, this collaborative filtering as presented here seems really simple. You just have a user and you have a movie, and then you try to predict the score that user would give the movie. But in general, you could have much more information than that. You could have a lot of auxiliary information about each user, like I don't know how often they've gone to movies, or what kind of computer they like to use, what area they're in. You could have, it's possible to have a lot more information than just a user ID. And on the other end, the movie ID, you could have a lot of information about the movie, like what year it was made, what genre it's in, who the actors are, whether it's won Academy Awards or not. I mean, you could come into this collaborative filter with a lot more information than just user and movie. And I wonder how that can be done.
Maybe we can create multiple collaborative filtering models and do a majority vote kind of a thing. to make
Also, I think, I mean, wasn't that kind of the transition of him towards the tabular neural net? That basically, if you have all these kind of extra things, you basically transition into a neural net, and there you have encodings, embeddings for all these kind of different entities, and therefore you get kind of a bigger space, embedding space. Not
Yeah, I guess
Yeah,
I
but-
have trouble visualizing, you know, when you have all those extra data on the users and the movies. Now I can't visualize it as a simple matrix multiplication.
Yeah, I think it
matrix
gets more
factorization
fuzzy.
problem.
I think it would be multiple things. Multiple types of items for single user, and we'll build multiple collaborative filtering models for user item 1, then user item 2, those kind of things, and we'll do majority vote to make suggestions.
Or do you think an approach like, for user 1, user 2, user 3 will create an embedding for, all these, like the first user feature, second user feature, add them up and use that final, embedding in place of whatever we had till now?
I didn't get your question.
Like you mentioned that we have basically, instead of users and ratings, so we have multiple features for that user, like whether he's from this region or maybe something like that, and we'll create an embedding for each of those features.
Yeah, so those are user features. So users are going to be the same people. Items, since we're talking about different, there are so many things, right? So
Yeah.
so those are kind of different items. Users are going to be the same, the items are going to be different. Like then user movies, then it should be devices, the kind of computers these users are, the user is using, and then the kind of places he's shopping at, those kind of things.
Yeah, I was thinking that, okay, suppose you have, this matrix on the left that has to do with the users, and he said that there could be 5 things in it or maybe 40 things in it. I mean, maybe you could hijack some of those columns as, and force them to correspond to user features, and then
Yeah.
initialize them to what you have the user features and you encode them some way, like, region of the United States where they come from is, 1 if they come from the West, or 2 if they come from the Midwest or whatever. And then you force those values into those columns instead of initializing them with random numbers. So you're trying to give that matrix whatever information you have and force it to use it in the remaining, and make a neural net solve for, well, I don't know, maybe I'm not being clear. I'm just trying to figure out how to, because on the one hand, you're letting the computer learn all of the features related to the user, but what if you already have a whole bunch of features related to the user that you want to put into the model? I'm trying to figure out how you would do that. And the same thing goes with movies.
Is there a way to do that? Because if you provide it to a neural net, it would change the weights, right?
Yeah, that's right. Yeah, I just thought of that while I was talking. Yeah.
I think it would be something kind of a additional step, probably, what you are saying. Like first do the collaborative filtering, then use the fixed values as well to make your actual recommendation.
Yeah, I think you could do the collaborative filtering. You get your latent factors, like an example of 5 factors. That is a vector that you can calculate based on some given inputs. And then, you could say this person has this vector of latent factors that kind of describes that person. And then one thing you could do is you can try to detect differences from that. You can say this person liked this movie, and is that surprising or not based on the latent factor calculation that you do for that person. Is it expected that this person would like this movie very much, or is it surprising that the person likes this movie? Because it should put them into a different, set of latent factors. So in that sense, it's an anomaly detector. Does that make sense?
Yeah. Go ahead. Sorry. I guess I'm thinking about how would you put into the model things that you already know about the user in the movie. Instead of letting the network solve for them, you want the network to start with them and use them. I mean, I don't know.
Yeah, that definitely one technique, like somebody said, is you already have done a pre-processing or pre-step on some other data or some older data or historical data. And for example, gone through the entire collaborative filtering process with a number of latent factors, and you've figured out what they are. So now with new data going forward, you can put this you can categorize this person based on the latent factors, and then you can see with any new data what is their latent factor vector, what does it look like, and is it what you expect or not, for example. How different is it than the latent factors that you calculated from the historical data that you've seen already? I'm talking more in terms of time series data, ongoing data.
Okay, guys, I'm conscious of time and also that we started a bit late. The next section is on, I've lost my place here, on the collab learner and so on. So what do you suggest we do? Because I think we're, we started late, it's 5 past. What do you suggest we do in terms of, this is pretty much halfway through lesson 5. So we have 2 options. One is to continue and go on to collab learner and talk through some of those things. And try and do that in 10, 15 minutes. The other is to postpone the discussion for next week. What's the consensus? Well, I guess we got another lesson on Tuesday, haven't we? So you got more stuff to cover. So do you guys favor us just cracking on with what we're doing and continuing, or stopping? What's the vote?
I probably need to go myself.
Same for me, but yeah.
Same.
We also have one lesson. We also have 1 week without a lecture, so we could maybe do that as well.
Yeah, sure. So then, but the thing is, next week we've got the lesson on the Tuesday, whatever, and on Saturday it would probably make sense to cover that stuff off, and then maybe we then come back to this then with the collab learn and so on, because I think it was really helpful stuff, but stuff that would take, I think it would take us time to discuss and so on. So it's definitely not something you probably want to rush. Should we park it then for maybe a part of next week and a bit of whatever we're going to cover for lesson 6.
Can you quickly remind me again what was the end of the lesson?
So we've still got to cover things like collab learner, the weight decay, a little bit on gradient descent, and he goes through those examples. And
I think, we can postpone the collab stuff because I'm not sure how the course progresses, but I assume that collab filtering is kind of a niche thing in the grand scheme of things. So it's probably okay to shift that for a week or something. I don't know.
No, it's collab learner with, sorry. Yeah, sorry.
Yeah, but I think weight decay and is gradient descent and Adam, that would be important.
Yes.
Yeah.
So should we do that at the start of, so maybe we give ourselves about 20 minutes for the start of next week to cover some of this stuff potentially, and then we go ahead with lesson 6, or
yeah, that sounds fine. That sounds good.
Yeah, maybe we can just make next week's meeting like 15 minutes longer by default, and then
yeah, that's fine too.
Sounds good.
Okay.
Yeah.
Okay, any other thoughts? Again, my apologies for not figuring out how to log into Zoom and But any other thoughts on, or any other questions around stuff we've discussed?
No.
Okay, cool. Then we'll speak next on Saturday.
Okay, thank you. Thank you.
Thanks.
What's your name again? Again, your screen
I'm
says
John. I'm John.
John. Okay. Thank you, John.
Okay, great. Thanks, guys.
Thank you.